So this particular technique is very, very useful in many of our practical purposes. Sometimes we call it prediction. We have two types of interpolation. Interpolation means if you have your data points or available for a particular observation or experiment, then by using those data points, you can calculate or obtain an estimate of your function or observation that were not available to you during experiment or in any observation. So what we can actually do in this case, we can apply our numerator there just to estimate the value, an interior value between your the lowest and highest value of your interpolated observation, the independent variable. Or we can go beyond this. For example, say we have a situation like weather forecasting. Do you have any idea how forecasting is made or how forecasting is done? Do anyone have any idea about it?
No, sir.
No, sir.
Okay, have you just inquire about it because you are the science student and the thing that is there happening is very much probability or in general physics and science. As a science student, actually, what is your self-exploration particularly? Can you tell me that apart from what you are doing in your classroom, and many of you are not actually engaged to the extent we expect, how you are consuming your time 24 hours? Can
Studying
you tell me?
robotics and some Tesla model car.
Eating and model cars. Okay, are those things are very much understandable to you rather than some practical things? Can you design, for example, you have to set your priority first, that in which ways you need to move. The thing that is around you that you are using every day, you don't have any idea about. You are thinking about something, but the logically what is correct? Because in your robotics, many things are there involved. And in my understanding, students are building robots. Those robots are actually funny things. They barely resembles a practical purpose. What they are doing actually, the design is always there available. Programs available. Components are available. They are bringing the component, joining them together, replicating the program, just changing few lines. He doing it. That he designed a robot. Yes, you can. But the purpose is what? Is it the to play football, or their purpose is to follow a line, or a purpose is what? Some are doing some good things, no problem. Where are you? My priority will be first. I have to understand something that is around me. Later, I will do the. But one thing is that okay, you are using technology with you. You have your with you huge time in the online. In many of the cases, you are spending your night there. I don't know what you are sleeping in the daytime. So, if you go, for example, in a reverse way against the nature, okay, be careful about that. Allah has made your night for rest and sleep, along with some prayer, and your day is for your exertion and work. But you guys and we actually make it the reverse. For this reason, probably we are facing something never ever in the human history. Still, we are not waking up. Okay, so be careful about that. Learning is not something like that. It will be coming to you like a magic. Okay, you have to feel thirsty. There you will find where the water is. But you cannot expect that you are thirsty. Your water is coming to you. You got my point. So you do your robotic. No, along with doing this thing, you do something that is very close to you, and you are in them. Okay. So a natural question can come. Anybody can ask you this. You are a student. Can you tell me that how the weather tomorrow is it be rainy? Would it be cloudy? Or even sometimes the forecasting can be made over an year. And in many of our coastal regions, this weather forecasting is very important. Even the hourly forecasting is also important. Although our people do not care about it, because the life here in this country is very cheap, the most cheapest thing probably you will find in the world. Lots of people are dying, drowning, but they never care about it. Still, they are doing the same thing. Okay, people are saying that you infection, COVID, you are not going elsewhere. Probably, are you confining in your home? I am not talking about okay, many of my colleagues. Okay, when I call them to come to the university, they don't have time. Even they are saying that we are in lockdown. But are they are in lockdown? They are going market, they are going to shopping, they are going to restaurant. But whenever something is there related to the real tax, then many reasons are coming. So be careful about that. Time is will not, no matter it's pandemic or something like this, you have to utilize your time in a very effective way. Many people are doing many good things during this time. This is also an opportunity. Sometimes you see that your disaster also brings some opportunity. And that opportunity, if you cannot utilize it or grasp it, probably most loser something. And the most what you call what you call worst victim of this disaster. Okay, no problem. I am encouraging you to do whatever you like. This thing, I am also encouraging you to do something there that is around you. At least you explore something. It is not expected that you will learn everything. Okay. Just wait a bit because Vice Chancellor phoned me. I have to receive it. Sorry for interruption. Actually, we are having a very huge regarding admission or something like this. I don't know how university in this year. So let us, let us get about I was talking about. Go into the topic first. Okay, our is interpolation means if we have a set of data points, by using those data points, we can estimate an intermediate data point, that is called interpolation. And if our estimation is going beyond that region, we call it extrapolation, like projection or some lots of statistical and other are also involved in many of our practical purposes. But what we will be doing, of course, giving a very simple introduction on it, on the gravity of our application at this stage, extended for, and we get some practical application of this. So in your book, you can start with article 18.1 and go all the way. You will find the thing there. But here I will some, okay, even I can show it the thing to you. Actually, our concept is, if we have our data points or observation point available, then depending on data point, we can easily find an equation that will satisfy or passing through all the data. This is the thing simple, already learned in your geometry class or in algebra. For example, if we have our two data points, then what is the hey, can anyone answer this question? Going to second man. You understand what is the question I have asked to you?
No, sir. Can you repeat again, sir?
If we have our two data points, what mathematical function could represent these two data point best? Intermediate level first year question, okay? If you have point there, say this is your x1 and this is your y1. Another point is there, this is your x2 and this is your particular function that can that satisfy, right? Is it like
Yes.
you want to this thing actually, you will see plus one data points. Then we need a polynomial of order n. That will be passing this four data point n plus one data. And the logic is simple actually. If we have a straight line data points only, one point is f1 x1, another say y1. You can call that y1 as say x1, call y fx2. You can, if we have points with us, then we have a line pass x1 and x2. Then be equal to fx. Then you find it by using your simple similar triangle rule that I have discussed in one of my classes. But the question is whether the point that you are predicting is actually what we want. It depends on one of the important factors is that if you know the variation of your data between these 2 points, it can be something like this. Then how to curve is the actual variation of the function between these two data points. We are approximating this line, then this is the value you are predicting, but actual value is this amount of will be there. So in this way, calculation, if we have our three data points available to us, then that prediction will be a bit better than the straight line, because we can easily derive an equation. Equation can pass through this order of unity curve we have a higher. Okay, in this case, when we are using a straight line, we call it linear interpolation. If we are using a polynomial, the polynomial interpolation, and the order depends on practical problem. If we are using second order, we call it quadratic. If we are using a third order, it becomes polynomial. This is what the scenario here described. If we have 2 points in a straight line can be the interpolating polynomial. If we have a 3, we have value 4, we can have. Question is to derive the of these three cases. In the first case, we repeating it. It is you know how to derive the equation of a straight line if 2 points are given. Now, if we have a 3 point there in B, then the polynomial we have our 3 points, so order of the polynomial will be equal to 3 n minus 1 n plus and n polynomial. Then in that polynomial, how to find the equation of the polynomial? It is actually not that. You can use this simple concept to find equation of the case. In this your polynomial, okay, this is your we call. If it is second order, we are representing this polynomial, say f2x. Then f2x can be there a0 plus a1 into x plus a2 x square. Our objective is we have to find the value of a0, find the value of a1, find the value of a2. In the curve fitting technique, we use a huge number of data to optimally find the value of a0, and a2. But this is not actually curve fitting. In this case, we are designing a polynomial in such a way that all the data points will be satisfied by the polynomial. So in this case, what you can do, if you have a available there, consider that this point is x, this point is x, this point is x3. Corresponding value of the functions are there, say to x1. This is your f2 x2, and this function value is f2 x3. Then we can put this function value here to obtain the three equation. One equation will be equal to f2 x1 is equal to a0 plus a1 x1 plus a2 x1 square. Your second equation will be a2 x2 equal to a0 plus a1 x2 plus a2. Your third equation will be x3 is equal to a0 plus a1 x2 plus a3 x3 square. Now tell me, can you find the value of a0 through a3 now?
So should a2 x3 square?
আরে দেন ওই ভ্যালু না দেখে তুমি ভাবে এগুলোর ভ্যালু বের করা যাবে। এটা সিম্পল একটা রাইটিং মিস্টেক, you can easily correct it. How can you find the coefficient values a1 if you have this equation with you? This answer can be given by class 8 student, okay? Because you have your three equations and three unknowns are there. You can easily simultaneously solve this equation of your, then that will give you f2x that will pass through all these 3 points. Is this problem is actually an engineering student problem? It is the problem of very elementary level mathematics. That if you have your unknown there 3, then if your 3 points are given, then you can say solve this equation to find the unknowns. A similar thing is there in BC. Okay, in your B, in your C, how many equations we will have? How many points are there?
4 points are there.
If you 4 points are there, then what will be the order of the polynomial?
Order.
Fourth order. If you have a
The
fourth
third
order
order, sir,
polynomial,
third order.
if you have a fourth order polynomial, then your polynomial is equal to x plus a2 x square plus a3 cube plus a4 x to the 4 unknowns are there. Can you find 5 unknowns by using 4 points?
No,
Third order equation.
Answering, okay. For example, speak something, okay. Do not utter something that actually consume time, okay. We have no security. Please be careful about the question, okay. That means you need a third order equation. In this case, how many unknowns will be there? We will have 4 unknowns, okay. You have to solve equations, but unfortunately, if you want to go in this way, you will find a number of equations equal to number of unknowns. Then you can deploy your simultaneous equation solution algorithm there to solve them. But it happens that the coefficient will very ill post. As a result, ill post problem should be handled very carefully, that we discussed in earlier chapter. Now we will be going to some other alternative approaches, although the things are very similar to polynomial that we discussed earlier, but it will not need the solution of a simultaneous equation. Rather, by using a simple divided difference, we can easily calculate the coefficient of the polynomial that is discussed there in Article 18.1. It is called Newton's divided difference interpolation. Polynomial, your polynomial general shape of the polynomial will be equal to, this we'll discuss later. First thing is actually already I have discussed. Okay, first order, in your first order approximation, what we usually do, if we have our 2 values available with us, then what we can do, we can find the equation of a straight line that will be passing through these two. That straight line can be used to find or predict or interpolate a value that lies the upper or lower limits of your straight line. So this is called linear interpolation, and the equation is 18.2. The equation by your own. It needs the similar triangle principle just to find the height and base ratio to find the equation. Okay, this is illustrated there in 18.2. You see that your solid curve is actually, if your solid curve is the, then 2 points are given. One point is x0, another point is x0, and another point is what, x1. Then this is your actual. Then what will happen if we draw a straight line going all the way in this way, that this is what the equation, we call it f1x, the first order interpolating polynomial. If we have a 2 point x0 and x1, and the corresponding value of your function f0 and f1 are available with us. Now, if you want to predict a value at x, that is between x0 and x1, then linear one, we are obtaining this value f1x. Actual value minus the value that actual value, take the multiply it 100. This is the percentage of actual error. General, you can make a general trade-off, okay? That how can we improve that error by using the 2 point? Can you tell me from by using your common sense that how can we proceed in a way so that that error will be minimum, will be reducing? কোনো আনসারই নেই, চুপচাপ বসে আছো, কি আসো এইদিকে নাকি নাই?
Sir, by iteration.
By iteration. Simple common sense. Example, this point, for example, here, if we bring that point, for example, in this location, and if we bring this example, straight line will be something like that. Then our predicted value will be there. Then you see that previously the error is this amount, but now you have this error only, okay? Error is this. So this is the simple thing that you do not need engineering to understand it. You can bring the thing closer so that actually calculating, for example, the height and base ratio is nothing but we are calculating the slope of this line, isn't it? If we are going to, for example, if your point are coming closer, then very closer to the what you want to know. In this way, actually, we can improve. An example is there. Try to do this example where your points are varied. The values of keeping x0 fixed, x1 is varied, or you can go in either ways and try to calculate or interpolate the value of a function. The example was you have to predict the value of log x, then x equal to 2. The true value will be known to you. Then you change the value of x0 to x1 and explore that how your results are improving with the choice of 1 or x. So this is your linear interpolation. Then if we have interpolated polynomial, that is, if we want to improve it, what you can do? If you want to improve it, okay, this is okay. You see that your value for your x1 value is shifted, and how predicted value is improving. Now we have our another refinement. In this case, what actually was the solid curve that you have seen there. Okay. Not it. So about there, we just use this to predict. Now your curve was like this. This was our structure. Now if we point here, for example, then we will have 3 points now. One point is say x0, another point is x1, another point is equal to fx1, the value of your function is fx2. Then if these 3 pair of coordinates are available with us, then we can easily derive like our general equation that I discussed at the beginning, that if we want to use a second order polynomial, how many constants we will have? We will have 3 constants, okay? Then we can determine this 3 constant by using matrix solution that we have discussed earlier. But here in this case, in the Newton technique, that matrix calculation is avoided by using another alternative representation of the polynomial. unknowns. So here in the case for a second order polynomial, your interpreting polynomial is defined in this way. If we just if we multiply the term and rearrange it, it can easily be put into this form. No problem. Now, in this case, what you need to do, in this case, you need to find three unknowns, A0, A1, and A2. How to find this, we discussed at the beginning. This equation, we still have also have B0, three unknown B1 and B2. There exists a relationship among these three unknowns and these three unknowns. That is derived, you do it. Now, if you want to keep our polynomial in the form that is there in 18.3, we have to find the value of our 0. For example, if you 0, that your B0 is equal to F20, F2X0. If we put the value of A, and as well as we will find and by a simple manipulation, what you can do, we can easily put them into a standard form of derivative. Okay, for your B1, we can find 18.5. And you see that is it not the equation of an approximate equation of a derivative, or we call x equal to x2 in our equation of general form of quadratic equation? Then you will find and rearrange it, you will find B2, that B2 is equation 86. What is this actually? Your first term x2 minus x1 divided by x2 minus x1, what is it? Is it not the derivative of your?
Yes, sir.
And your second one is also a divided difference for x1.
Yes,
So
sir.
you are you see that in this case you are differencing two derivative first order and divided it with a value equal to the span over which you are calculating the two derivative first order. Is it not a second derivative?
Yes, sir.
You can compare this equation with the second derivative equation derived in chapter 4. So you see that actually in the second order polynomial, in the first order case, we usually use here interpolation of derivative first order, and it becomes a straight line. And when we add a second derivative there, term B2, adding a curvature to your interpolation, the order is 2. Then in interpolation, polynomial will be a second interpolation. Then how to calculate it? Because you see that in this case, you need not to have any simultaneous equation to be solved. What you need to do, if you can have a data point available with us, then we can easily calculate equation 18.5 and then equation 18.6. Even illustrate a table is there in your book. You can easily verify it. I will show it a bit later. So before going to that, discuss it by using 3 points. We calculate. The 3 point is needed for quadratic interpolation. Consider that we have a table. That table contains these data. How many data we have? Say 3 points. Okay. Say this is your x value, this is your fx. We are putting a subscript there, that means it is a second order polynomial. Say your x0 value is there, x1 value is there, x2 value, corresponding value of your x equal to f2 x0. This is your f2 x1. This is your f2 x2. Our second thing is what? We have to calculate the derivative, first order derivative. We have to calculate the second derivative. We are representing by delta 1 and delta 2, something like this. We have, fine. Now, in order to calculate this term, but this is equal to the first derivative calculated by using f0 and x1, isn't it?
Yes, sir.
This entry will be equal to what? f2 x2 x0 divided by 1 minus x0, isn't it?
Yes, sir.
Then we are using these two to calculate it. Now our next entry here will be equal to what? We have to use these two to calculate the derivative, isn't it? In this case, your derivative would be equal to x2 minus x1 divided by x2 minus x1, isn't it?
Yes, sir.
Do you have any other derivative there? First derivative? No. Then next, there you see that your table entry is reducing to 2. Second, because we cannot go beyond this because only our 3 data points are there. Then we have to calculate the second derivative. In this second derivative, we have these 2 entries only. If these 2 entries are there, what you can do by using these 2 entries, can we calculate the derivative there?
Yes, sir.
And that derivative, you can call it, say, delta 1, 2 minus delta 1, 1 divided by
x2 minus x0.
x2 minus x0. Isn't it?
Yes, sir.
The end point and the last point. You see that we are gradually in a that your derivative is gradually increasing, and you see that using these 3 points, you don't have any derivative f3, okay? Because third derivative is not available there. Your polynomial is a second order polynomial. Okay, so in this way, we can, if we have our, we can easily calculate b0, we can calculate b1, we can calculate b2. That will not need any solution of simultaneous equation. This is what the simplest form of our Newton polynomial, and it has been generalized for an nth order polynomial. You will see that the calculation is very simple. In the nth order polynomial, you will have nth order derivative non-zero. N derivative, you can easily calculate this by using this tabular technique. Okay, this example is already illustrated there. Try to solve it. I will be there at 18.13 just to show you the general form. Okay, can you see this table? Figure 18.5.
Yes, sir.
Okay. I hope our foregoing discussion will help you to understand the entries of that table. You see that in this case, you have your, in this case, we have our 4 or 5 data points. 4. Then this is what the number index, nothing to do, just to designate how many points you have. About and y values, fx values given. Now the thing is that what we need to do, we have to calculate the first derivative, second derivative, delta 2, third derivative, delta 3. So using your 4 points, your polynomial will be equal to what? Your n plus 1 is equal to 4. So n will be equal to 3, isn't it? You need a third order polynomial or cubic polynomial to fit it. And how many constants we have in Newton polynomial? B0, B1, B2, and B3, isn't it? So how to calculate B0? B0 can easily be calculated because B0 is equal to F0. So by using first data point, you can easily calculate the first constant. Next thing is to calculate the other constant. So before going to the math, what you call using without equations from the derivatives. You see that just like our previous example, you use your first two data to calculate first derivative. That derivative is represented by f in this book fx1 x0. That is equal to what? This is simply equal to fx1 minus fx0 divided by x1 minus x0, isn't it?
Yes, sir.
So then we can calculate the next derivative by using x1 and x2. This is what it is. This is equal to x2 minus fx1 divided by x2 minus x1. And your third term will be equal to x minus x2 divided by x3 minus x2. So your first derivative is calculated. Now we can go to the next step. Just to use your first two to calculate your second derivative. You see that your index are increasing for better understanding. Okay. You see that you have x2, x1, x0 is the second derivative, and that is equal to actually fx minus fx1, x0 divided by x2 minus x0. Is it not the second derivative?
Yes, sir.
In the same way, you calculate the second derivative and your span will be equal to x3 to x1. Then you have your two derivatives there. You take the difference and divide it the starting point and the end point. This is equal to fx1, f0 divided by minus x0. Okay. That's why your third derivative is calculated. Because you have our 4 point, you have no, for example, scope to go beyond this because the other derivative is there, higher order derivative. Okay. In this way, if we have our derivative calculator successfully stable in this way, then you can easily calculate the coefficients associated with your polynomial, and that will not need any what? A solution of simultaneous equation. Now, from there, okay, example is there with n equal to 3. You can easily solve it. You see that by using 4 data points, your first derivative, 3 first derivative will be available. Calculate T derivative, we can calculate the second derivative. We have 2 second derivatives. They are these second derivatives are this. Then using these 2 second derivatives, we have to calculate the third derivative. The third derivative is this. Then your equation will be what? B0 plus B1 into x minus 1. Because your first point is 0, second point is x1 equal to 1. Then third point is B0 minus x minus x1 into x minus x2. So x2 point was therefore similarly you can go find the final term. And you see that this is what the interpolating polynomial cubic polynomial. And if you want to compare the result, okay, you can just compare it using the linear form first. In the linear, you approximate the value. And for the second order polynomial calculate, for your third order polynomial, you calculate the value. You can easily how you approximate the vertical function is improving and how the error percentage. In this way, you have our interpolating polynomial error calculations are there. It is based on the similar technique that we Taylor series. Write a program there by a simple program, and this curve actually shows how the errors are decreasing. And your dotted curve is a true error. You see that if we have our function known to us, then only when we can calculate the true value, Otherwise, we cannot calculate the true percentage of error. So the alternative is actually calculating the approximate error. The approximate error is calculated by using the calculated values. In this case, you know that the accuracy of your interpolation value is increasing if we use higher order polynomial. So you can start with your first linear, predict the value, then you increase your polynomial order by 1, then again you estimate the value. And you can find a percentage of approximate error by using the value of your higher error, and error will be there. If you want to, if you doing on calculating the error with respect by increasing the number of polynomial. For example, say if we have a polynomial n order, is then oh,
স্যার প্রায় 7-8 জন স্যার মিটিং থেকে ডিসকানেক্টেড হয়ে গিয়েছে স্যার।
হয়ে গেছে ডিসকানেক্ট।
স্যার আজকে ঝড় বৃষ্টি তো স্যার, পার্টিসিপেন্টস লিস্ট চেক করলে দেখতে পারবেন স্যার
I
ক্লাসের
will
শুরুতে।
but
স্যার
sometimes some people
ওকে স্যার ক্লাসের শুরুতে যে কয়জন ছিল এখন অনেক কমে গিয়েছে স্যার, ওরা ঢুকতে পারছে না এখন স্যার, ওটা আপনাকে জানাতে বলেছে আর কি স্যার। দেখেন স্যার মাত্র 29, শুরুতে 37-38 ছিল স্যার। ঝড় বৃষ্টি তো স্যার আজকে নেটে অনেকেরই সমস্যা করছে স্যার।
because I have done unlocking the team. But problem is there, some are abusing, okay? That is what my question. So now they can join. Tell them to join again.
ইয়েস স্যার, বলা হয়েছে স্যার।
Okay, you see that error curve, okay? How to calculate the error for approximate error that I want to discuss. Because I am having the problem recently with this software, okay? Sometimes that annotation is not appearing free, something like this. Every invoice, their own platform, they are using IoT, repeatedly telling, but nobody is hearing. They are all using the free stuff. Okay, yeah, how to, for example, a true error can be calculated by using true values. Now, if your function is not available to you, you cannot calculate the true values, okay? So then what you will do that, you calculate a value of your function, say n numbers of polynomial, say this value is say x predicted xp, then you have calculated a value for n minus 1 order of the, then you will have a difference, okay? If this difference is 0, that means your prediction is not even after increasing the polynomial, so you can stop your calculation. But that will not be the case in most of the scenarios. What you can do that n into xp and calculate the absolute value, multiply it by 1. That is what your absolute percentage of true error, okay? Approximate error. So you can approximate error can also be used to what you call examine the goodness of your prediction. So in particular, you can easily plot it and verify it by using the ingredient polynomial and calculating the error. You see that both the error curve actually had the same trend. The faster. Another scenario for this particular problem is this. If we start in the reverse way, that means we have our 3 points, for example, given. Our curve was some 3 points here, one point, another point was there, another point was there. Our predicted point was this. This is what the predicted point, okay, where we want to predict it. So here in this case, if you want to predict, prediction is made in the reverse order. Then you will see that even it will going in this region, it will be coming first. And that is explained there in your book is that if we have our point that in the prediction point, then it will be converging actually faster. And I am saying if you go through the text, I know that you are reading or not, but you will find many interesting behavior there that numerical technique are some sort of experiment. And you will not find, for example, an algorithm that is suited for conclusion general by solving a particular type of problem. But a trend can be observed. So this is what this thing. It is not absolute that this will be valid for other type of problem. But your error will decrease if we can have a more point and we can fit a polynomial with higher order. Some of can continue more than others, and that can be analyzed by using some other technique that we will be discussing afterwards. So we have our another class. So if you want to summarize our language Newton's interpolation, actually it is something like that. That if we have our n plus 1 numbers of data point, then we can choose a polynomial that is less than n minus 1, so that we can pay between two data points. But for that your prediction error will be decreasing and prediction will be higher. But the thing is that if we have a higher order polynomial, then we have to calculate. We have to have our algorithm there that will give you more unknowns to be calculated. But we have two approaches there. One is direct, where you can choose a polynomial in the form, standard form, say fx is equal to a0 plus a1x all the way. In such cases, in order to find unknowns, then if we have all numbers of unknown numbers point and you will have simultaneous equation there, you can easily apply the algorithm that we use for solving simultaneous equation to find the unknowns. But if you want Newton's divided difference type algorithm, in this case, you can form a table. That table is actually can be easily formed by simple differentiating and dividing. So it will not involve any what we call solution of simultaneous equation, because solution of simultaneous equation actually the type of equation that we have, you can easily examine the general nature of the equation. Actually, if you want to use equation there, nature of the equation is something like this. If you want to find a three order, it will be equal to x1 and x1 square, another would be equal to 1, x2 square will be 1, x3 square, something like this. This will be the nature of your matrix. Okay, this type of matrix is ill-posed. We have discussed about conditions and ill-posed problem earlier. Okay, a minor variation of your parameter will drastically change your result. In addition to that, it is very prone to doubt. For this reason, this direct matrix type algorithm is rarely used in predicting or interpolating functions. Okay, the Newton's one of efficient formula that we usually use to interpret the function. Now another class of interpreting function we call it Lagrange one. This is also not difficult to be understood. Let me just, we have a problem with this share. Is it visible now?
Yes, sir.
Yes, sir.
Okay. Lagrange's polynomial has a root, for example, that actually represent the, you see that, can you tell me what is the thing that is going on? You see that your subscript Fn actually represent the order, okay? That means that is approximated in this way, isn't it? Can you tell
Yes, sir.
me in that sum, which quantity is unknown? Which quantity xi, is it known or unknown?
Sir, unknown.
How?
Uh, we don't.
In your prediction value, you will have some experimental data, isn't it? Those experimental data will contain the independent variable as well as your dependent variable at the data points. This is what the value of your dependent variable at the data point xi. This is known. Xi is also known to you. Xi is the discrete value. This is your xi, this is your fxi. For I equal to 1, this will be x1, this will be equal to fx1. So this xi is known to you. Because this will be, because if you have your 3 data points, then 3 values of xi will be available. But this quantity Lix, this is called Lagrange's polynomial, that is not known to you. Okay. So for each of your data points, you have to use a function. That function will have a shape. So that will be valid between 2 data points. Okay. It is very similar to, we can call, for example, this L1x as basis functions. I have described basis function during curve fitting. And again, I am telling that you know this thing from your Fourier series. Okay, you see that Fourier series, you use basis function that are sine and cosine. We have approximated a function, say fx, by using what? By cosine functions. So these sine and cosine functions, I am not completing it, you do it. Sine and cosine functions, you know the nature. They are the basis functions that are available with you with harmonic frequency. Only thing is there, we have our amplitude factor available, Bn and An, that we determine by using LMSC criteria. A square of mean, a square of error should be minimum. But we have another representation, equivalent representation of the Fourier series. Do you know what is that representation? We have again been in this way, c equal to minus infinity c e to the power j omega 0 say nx. Can you find have you ever seen this type of representation in your Fourier math?
Yes, sir.
What is it?
Sir, I don't remember the names.
Any one of this batch can remember it? What is the name of this form? I am very much afraid of your future, okay? Because you are already, you attended 4 courses of mathematics. And thing will not again coming back. Whatever time lost time, and okay. Once it is lost, you cannot, for example, bring it back. Be careful about that. ক্লাস হলে তো রেসপন্ড করতে না পারলে ক্লাস থেকে অর্ধেকই বের করে দিতাম, কিন্তু পারতেছি না। এটা in order to understand the thing, do you need any new mathematics? Is it not your intermediate level algebra is more than enough to understand it? that you know that your cosine function cos x can be represented by e to the power what? Hey, is there anybody who don't know it? Be
Euler's
represented
equation.
by e to the power
J
jx
omega
plus
x.
e to the power minus jx, then
So divided by 2.
divided by
Divided by
2.
2.
And if you have a sin x, this is equal to what?
E to the power jx minus
jx.
Isn't that?
Yes,
If you have this thing with you, cosine functions can be represented by exponential functions with complex argument. So your Fourier series can be easily represented by complex argument because they are the part of your cosine and sine function. Actually, for example, if you have function sine omega 0 at t, that is nothing but it is the real part of, it is the real exponent j omega j n t, isn't it?
Yes, sir.
Yes, sir.
Now applying this is identity. By using that Euler identity, what you can do? You can easily convert your exponential form into an equivalent sinusoidal form or trigonometric form is the real form into an equivalent by exponential. Infinity, say coefficient is Cn. E to the power j and c x. What is the nature of Cn? What will be the nature of Cn in terms of mathematics? Because you are obtaining a real function ft, but in your sum, you have a complex function. How can one obtain a real function by using complex function? No idea? Hey, how a real number can be obtained from a complex number?
by multiplying it with another complex number.
By
By
multiplying with the
multiplying
conjugate.
it, okay, we have a complex number x1 equal to x1 y1. We have a complex number x2 equal to x2 plus j into y2. If we multiply z1 into z2, it will be a real number.
No, sir.
We have to
Shall I keep-
multiply it with the
Sir,
conjugate of
x1
the
plus
complex
j
number.
into 0.
Multiply with conjugate complex.
If we multiply it with a complete conjugate, that means if we have a 1, multiply it with a complete of 1, then it becomes real. Okay, good. Now in this series, we are not multiplying, rather even if they are added, it will also be a real number, isn't it?
Yes, sir.
What will be the magnitude? Will it not be into?
Yes, sir.
And what is the magnitude of this product?
Z square.
X1 square plus y1
Z
square.
1 plus 1.
So x1 plus y1 whole.
নিজে নিজে বের করো। Okay, the thing is that if we have number is complex, our signal is real. But we have a complex sum there. That signifies that the coefficients that is in the negative region, the positive, they will be complex conjugate pairs. Okay, your CN must be complex conjugate pairs, otherwise they cannot be summed up in a way with their weighting with basis function to obtain a real one. Very simple something, it doesn't need any new mathematics. In intermediate level understanding is more than enough to investigate the thing. So a basis function here we are also using, but that basis function is not actually a complex one, it will be a simple real one. I am leaving this thing at this point, okay, for you personal understanding to some extent, to the extent you can go. In the last class, probably I have given a task to you with the at least one or two students will do it. I am sure that not all will do it, but have you done it? Okay. All these things will be affect your final grading. Be careful about that. Okay, you are getting that we are not doing good in the quiz. We are not doing good in the thing that I am discussing in terms will be used